Hello, Stat 200, and welcome to Lesson 3. This week you're going to be learning about probability. Before we get started, I'd like to distinguish between four terms that you're going to see this week. First, probability. This is the likelihood of an event occurring. It must be between 0 and 1.00. The next term is proportion. Probability and proportion are sometimes used interchangeably. By definition, a proportion is the part in relation to the whole. Again, this must be between 0 and 1.00. A percent is the parts per 100. This must be between 0% and 100%. Often, you can take the proportion and multiply it by 100, and that will give you the percent. Note that there are some exceptions to the rule that it must be between 0 and 100. For example, percent change or percent difference can be greater than 100%. We won't see these until later in the course, though. And finally, percentile. A percentile or a percentile rank is the percent of observations below a given value. These are the key topics that you're going to see this week. We'll start with probability. Again, by definition, probability is the likelihood of an event occurring. It must be between 0 and 1.00. If you're computing a probability and it is outside of this range, then you've done something incorrect. The formula below in the yellow box is the formula that you'll see in the online notes this week. The probability of event A is written as P of A, or P and then A in parentheses. This is equal to the number in group A divided by the total number. Risk and odds. Students often confuse these two concepts. Risk is a probability. It's the number with the outcome divided by the total number of events. Note that this is the exact same formula that we just saw on the last slide for probability. Odds are the ratio of an event happening versus not happening. So the formula here is different. Odds are equal to the number with the outcome divided by the number without the outcome. If you have the risk, or the probability of an event occurring, you can compute odds as the risk divided by 1 minus risk. Let's look at a quick example. Out of 1,000 people, 50 will get the flu this year. The risk of getting the flu is 50 divided by 1,000, which equals 0.05 or 5%. Odds, on the other hand, are equal to 50 divided by 950. So the number who will get the flu over the number who will not get the flu. This equals 0.0526 to 1. You're going to see a number of different combinations of events this week, namely intersections, unions, complements, conditional probabilities, and independent events. Let's start by looking at intersections. An intersection is the probability of event A and event B occurring together. Your textbook will write this out as the probability of A and B. The online notes, you'll see the notation given here. Let's look at a Venn diagram. The circle on the left represents event A occurring. The circle on the right represents event B occurring. The overlap of those two events is shaded in blue. This is the probability of A and B both occurring. This is the intersection of A and B. Unions are the probability of event A or event B occurring. Your textbook will write this out as the probability of A or B. In the online notes, you'll see the notation given here. Let's look at another Venn diagram. Again, we have event A being represented by the circle on the left, and event B being represented by the circle on the right. The probability of event A or B, which we can see here also includes the probability of A and B occurring together, is the whole blue shaded region. So any area that is within A or within B, including the area A and B. A complement is the probability that an event does not occur. Here we have our sample space, so all possible events. Here we have event A being represented by this circle. The complement of A is the yellow area here. It is everything that is not in A. Most of the time you'll see the notation A with a superscript C. Sometimes you'll also see A apostrophe. In your textbook, it'll be written as not A. Let's look at an example. There is a 60% chance that your favorite team will win the next game. P of winning equals 0.6. So we've started by converting the percentage into a proportion or a probability. If P of winning equals 0.6, then P of not winning, or the probability of losing, equals 1 minus 0.6, which equals 0.4. This is the dark blue area in this chart. Conditional probabilities. You'll see a few formulas in the online notes and also in your textbook this week. Conditional probability would be read as the probability of A given B. So the line that you see in between A and B here is read as given. We're trying to find the probability of A given that we know event B has already occurred. Let's look at an example involving a contingency table. So here we have a contingency table concerning dog ownership in the rows and cat ownership in the columns. What is the probability that someone owns a cat given that we know that they own a dog? So we're really only concerned with the people who own a dog. Given that someone owns a dog, so given that they're in this row, what is the probability that they own a cat? Well, the probability of owning a cat, given that we know you own a dog, 85 out of 273. So 0.311. You could also compute this using the formula given above. Personally, if I have a contingency table, I find it to be much quicker and much easier to use logic and to just narrow down the contingency table to the row or the column that I'm interested in, but you'll get the exact same answer if you use the formulas from the online notes or your textbook. Finally, independent events. Events are independent when the outcome of one trial has no effect on the outcome of another trial. If two trials are independent, then we can compute the probabilities that both events occur by multiplying their individual probabilities. Note that this multiplication rule only works when events are independent. Let's look at an example. You are playing a game that involves rolling a die 2 times. What is the probability that the first roll will be a 6 and the second roll will also be a 6? The probability of rolling a 6 on any one roll is 1 over 6. Because these are independent events, we can multiply the probability of rolling a 6 the first time times the probability of rolling a 6 the second time. So 1 over 6 times 1 over 6 equals 1 over 36, or 0.0278. So the probability of rolling a 6 on the first roll and the second roll is 0.0278. Word of caution, this only works when the events are independent. If the events are not independent, then you cannot apply this rule. These are the concepts that you're going to learn in Lesson 3 this week. As always, if you have any questions as you're working through the online notes or the textbook, please post them to the Lesson 3 discussion board on Canvas.